For the first time, this is Dr. B Science classes where we try to treat science problems, okay, across board. And then if you are joining this class for the first time too, then you should know that you are owing me a duty, which is for you to subscribe to this channel. Dr. B Science classes. Just go to the bell and click there, click on all. And every class we've done before and the ones we are going to be doing, you will get them. Now, if you are an old member in this class, all you need to do is to share this class and tell your groups and colleagues and friends to do it, to as well share, and most importantly, to subscribe so that when these classes come up, they'll be part of this beautiful work that you and I are doing here. All right, so even on my Facebook is Dr. B Science classes. So all you need to do is to share and ask them to do what? To click on follow, and once they follow, it's okay. Now you can like, you can also leave comments. Like I've been receiving comments in form of questions, and we treat them as they come. Thank you very much, and happy new year again to all of you. Now today we are going to be looking at mass and volume relationship in reactions. Mass and volume relationship in reactions. I know that if you are a chemistry student or physics student or even mathematics students, you will know that what we want to do here has to do with some level of calculations. Now, some textbooks will give you some calculations that are lengthy, some will give you some calculations that are complicated. But here in Dr. B Science classes, we are going to break them down. Use the simplest possible method to solve these problems where you can be able to apply them in subsequent problems, in solving subsequent problems. Alright, so today you and I are going to solve a problem that has something to do with mass and volume. Alright, so we begin with a question that is on the board. So you are going to join me in reading this question out. So it is, what is the number of oxygen atoms in 32 grams of a gas? Okay, so we're asking what is the number of oxygen atoms. It's more like volume right now. It's more like amount. Okay, it's more like amount. Alright, so that we are looking at something that has to do with, remember that oxygen itself is a gas. So when we are looking at number of oxygen atoms, it's more like we are looking at the number of moles of oxygen atoms, alright, in 32 grams of a gas. So this is a gas, and more like volume, and we're talking of 32 grams here mass. Okay, so it's simple. We are given only one figure here, and data here, and this 32 grams. How do we go about solving this problem? Okay, what is the number of oxygen atoms in 32 grams of a gas? Now remember, gas, we have different states or forms of matter, and it is either matter is solid, matter is a liquid, or matter is a gas, and all of them have their different ways you can identify them. But most importantly, you can identify them in terms of the mobility of the particles or their various atoms, molecular atoms. Now you know that for solid, we are made to understand that the particles are tightly and rigidly held. And then for liquid, we are told that the particles are a bit mobile. And then for the gases, we are told that the particles of the gas are very, very free in nature, striking with themselves and also with the walls of the container. That takes us to the understanding of what collision theory is all about. But today we are not talking about collision theory, because in my subsequent classes here online, we have discussed exhaustively on collision theory. So go to my videos. You are going to see collision theory of gases well explained explicitly. So here, I just want to bring us that idea that we are talking about gases. Here, particles of this particular form of matter is quite very, very free in nature. Now, we are going to be calculating the amount of oxygen in oxygen atoms in a gas that is about 32 grams by mass. Now, I want us to know that there are specific formulas that are meant for the calculation of the determination of things like this. You shouldn't panic when you see questions like this. All you need to do is try to remember the specific formulas mathematical formulas or equations that are meant for things like this. Here you are to determine number of oxygen atoms. Number of oxygen atoms. More like say number of particles. Number of oxygen particles. And there is a mathematical representation or equation that calculates number of what? Particles. Number of atomic particles. And that equation is that equation will simply be described, okay, in this form where we have amount n is defined as the number of particles all over Avogadro's constant. Avogadro's constant. Okay. Now, this is the formula that will allow you to calculate for this. You must know that there is no mathematics in chemistry or physics or mathematics itself that does not have mathematical formulas. You need to understand the mathematical formulas to be able to solve the problem. The problem says, what is the number of oxygen atoms? And the formula that can be likened to this kind of a question is amount equals to number of particles over Avogadro's constant. Like I said, number of particles is something like you are saying number of atoms. Number of oxygen atoms, number of oxygen particles. And the only equation that is simple enough to give you the opportunity to determine number of oxygen atoms or number of atoms generally is amount equals to number of particles over Avogadro's constant. But do not forget that we will not be able to utilize the 32 grams that is given to us in this kind of equation. Because fine, we will be able to get the Avogadro's constant because it is a constant. Okay? And then the number of particles is what we are calculating. But we cannot say amount is 32 grams. No, it's not correct. Because amount itself has a formula. That brings us to the second step. So we will now say, but amount can also be defined as the reacting mass over molar mass. That is the second step. You are asked what is the number of oxygen atoms in 32 grams of a gas. We have mass, okay, given to us, and then we are looking for the number of oxygen atoms. And like I said, it's easier for you to start by identifying what formula it is that we have to use. And the first formula is amount equals to number of particles over Avogadro's constant. So we have to look for amount to be able to utilize the 32 grams given to us. And amount is reacting mass over molar mass. Do not forget that this reacting mass is the given mass. Of course, do not forget that the reacting mass is the given mass. The number of particles is the number of oxygen atoms. Simple. Just simple. Just that way and nothing more. Now, in that case, we are going to equate this with this. We equate this equation with it. Remember, this is amount. So we are going to take this and substitute into this place. We will now have reacting mass over molar mass is equals to number of particles over Avogadro's constant. That's what we're going to have. So if we are going to do that, that means we will now say this now implies that the reacting mass all over molar mass is equals to this, the number of particles all over Avogadro's constant. Do you see how the equation now reads? The equation now is this amount, which was originally here, what it entails, we equate it with this. So this amount will now become reacting mass over molar mass equals to number of, this is what we have here originally. We substitute this equation for amount here. This now gives us the opportunity to do our working. So we can now say reacting mass, which is given as 32 grams over molar mass. We are going to calculate it from oxygen. And then number of particles, we are going to work for it. And then Avogadro constant is a constant we already know. So we are going to now solve the problem in a very simple way now. Okay, so we will not be needing this equation or this equation again. This is the equation we will now need. So what we will do is to erase this from here. Okay. We erase this from here and solve the problem with this. Our reacting mass is what? So our reacting mass, or rather, let's cross multiply to be able to get number of particles. This is our concern. So we will now say this implies that number of particles is equals to, we cross multiply, is equals to what? Reacting mass times Avogadro's constant all over what? Molar mass. Yeah. So we have reacting mass times Avogadro's constant all over what? Molar mass. Now we have obtained this formula. It's simple now. Now reacting mass is what? Reacting mass is 32 grams multiplied by Avogadro's constant is a constant, which is 6.02 times 10 raised to the power 23 all over molar mass. Now the molar mass is the molar mass for oxygen. Is the molar mass of oxygen. Do not forget that the oxygen has an atomic number of what? Of what? Okay, I'm sure you already have that in your, within you. Okay, so the oxygen has atomic number of 8, and then remember that 8 times 2 gives you the mass number, alright, which is 16. Okay, but oxygen here is O2, so the molar mass of oxygen is 0.2, which is simply what? Oxygen is 8 times 2 times 2. This 2 is for this. So it means that we'll have 8 times 2 is 16. 16 times 2 is 32. So that means that the molar mass for oxygen is 32. It's 32. So we are substituting 32 for the molar mass. We are substituting 32 here for the molar mass. Because the molar mass of oxygen is atomic number 8 times 2, it gives us 16, which is the mass number. The mass number 16 times these 2 molecules of oxygen gives you 32. That is what the molar mass of oxygen. Okay, so this molar mass is 32. So in that case, we can easily end our discussion. So we can say therefore, this 32 grams can cancel this 32 grams. That's the molar mass. So this can cancel this with the molar mass. So what we now have is the number of oxygen atom, okay, in 32 grams of this is equals to 6.02 times 10 to the power 23. Now this is the number of oxygen atom in 32 grams of a gas. This should remind you of what Avogadro's number is. Okay, so this is what you will obtain at the end of the day. So if you were given something away from here, let's assume that what you were given here was rather 16, for example. So you put 16 here and divide. 16 will have gone 1. 16 will have gone here and give you 2. So you divide the 6.02 times this all over 2. Should 16 is what you had here. But because you had 32, it was easier for us to divide 32 by 32 and have just this factor out. So you can look at other problems that has to do with number of oxygen atoms in a particular gas, particular amount of gas. and try using this formula to solve it, and it will be as simple as anything. It is now it's very nice having these classes with you. This is just to let you know that solving problems in chemistry are not difficult at all. All you need to do is follow the right procedure, the right steps